Hi guys, I welcome you all to my channel CSNet Lectures. So in this session we are going to discuss about different algorithms of queue data structures. That is, algorithms are Enqueue and Dequeue. In the last videos and all, I discussed about how to do the operations in queue data structures, that is insertion, deletion, what all the different kinds of rules that are being imposed on this queue data structures. So now I am going to discuss the algorithms that is needed for implementing those manual operations. Okay, so here in this session we are going to discuss two types of algorithms, that is Enqueue and Dequeue. Right friends? And suppose if you would have not watched all those videos, that is the previous videos, I request you to watch and then come over here so that it will be very easy for you to understand. Right? Shall we move on to the discussion? Okay. So friends, this is the algorithm for insertion inside the queue data structures. Now, shall we go for discussing this algorithm? Right. So now, as the first statement, these are all the different variables that I am using in my algorithm along with item. These are the different initialization of variables which I am going to use it in my queue algorithm. Right. So, just make a note of it. Okay, so the first variable is n. So, n is equal to 5. So, what is this n? So, n stands for maximum size of the element that I am going to insert it in my queue. Right. So, next is queue of. This is an array data structure. I am going to use an array representation for implementing the queue concept for storing the elements inside the array. So, this is, I have not mentioned any size, because like this also I can give, or I can mention it as 4. Okay, so if I mention, it will become a static array. If I didn't mention, it is going to be a dynamic array. So what is the meaning? At runtime I can increase my array size, right? So next is F and R. What is F? So F stands for front variable and R stands for rear variable. So front is going to used for pointing to the front position of queue data structure, and R is rear, which is going to point to the last element of the data structure. I think so you might know what is the meaning of front and rear operation, right? So next is a variable item. So this is the variable name which is used for getting the elements from the user, and we are going to insert it inside the queue data structure, right? So these are the different variables which I am going to use, right? So next is, we are going to use a for loop for storing 5 elements inside the queue data structure. Okay, so what is a for loop? So for loop has 3 parameters, initialization parameters, then checking for condition checking parameter, and then increment and decrement parameter. So what is I? So I am going to use a instant variable which is having a data type as integer. Initially I am going to store this value as 0. So each and every time while executing this loop, based on this value of I, this loop will execute. Okay, so based on this value, conditions, and what operations that I have given inside this open and close bracket, based on this loop is going to get executed. Okay, so until this condition is true I less than n, this loop is going to execute a specified number of times. So now, shall we start? So initially I is equal to 0. Okay, so initially I is equal to 0, right? So now check the condition for 0 less than n. Is this condition true? Yes, 0 is less than n. So absolutely it is true. So now I plus plus, that is meaning is it will increment and it will keep the value for the next operation. Okay, so this value is going to execute in the next way, that is the next time the loop will execute, right? So now this condition is true. So now we are going to move inside this loop operation. So first condition is if R is equal to n minus 1. So before going into this, let me draw a queue data structure. So this is my queue data structure 1, 2, 3 and 4. Okay, so as this is an array representation, the index value will start from 0, right? So now Since the I value is true, so now all these if conditions, that is all these blocks which is being given inside the for loop is going to get executed. So now you see the first if condition, that is the first if conditional statement which is being given is if r is equal to n minus 1, then print as q overflow. So this is a statement that is being given. So let me explain you with an example what is the meaning of this block. So for example, let this queue be filled with elements. For example, 1, 2, 3, 4 and 5. 0, 1, 2, 3 and 4. So all the index values of the array have been filled with elements. So now f value will be here, isn't it? Now r value is going to be here, right? So now what is this r value now? So r value is 4. Okay. So now when what is the meaning is if the queue is having all the elements that is being filled inside this data structure, we cannot able to insert the elements more, isn't it? Because the queue is already full. How can I insert the elements? So it is not possible. So it will check this condition and it will display as queue is overflow, that is queue is full. We cannot able to insert the elements, so it will stop executing the loop operation, right? So now see r is equal to 4, isn't it? So n minus 1 is also equal to 4. So meaning is the rear pointer has reached the last position of the array data structure. So it is printing as q overflow and it is going to come out of the entire loop data structure, entire loop operation. So for that only I am using this break. So break is nothing but it is used for coming out of the loop operation. Okay, can you understand the meaning of this condition? Right. So now we will assume that queue is empty. That is, there are no elements in the queue. Suppose if the queue is empty, 1, 2, 3, 4, 5. Okay. So now you tell me where the front and rear pointer is going to point. Because the queue is empty, isn't it? There are no elements present in the queue. So where this front and rear pointer is going to be? So as I told in the last video, front and rear pointer is going to be outside of the data structure. Okay. So this is a queue data structure. So the front and rear pointer will be somewhere. So f is equal to minus 1 and r is equal to minus 1, isn't it? So now since this is a new queue data structure, we are freshly entering the elements. So for that also we are going to check this condition. Okay. So now if you see, this is false, isn't it? Now f is equal to minus 1 and r is equal to minus 1. See, this is the condition being given, initial condition. Since f is equal to minus 1, that is r equal to minus 1 and this is 4, this condition is false. So we are going to come out of this if condition. Next it will execute the else if part. So now if you see, f is equal to minus 1 and r is equal to minus 1. So now you tell me, according to this data structure, is this condition true or is this condition is false? So this condition is true. So write exactly. So this is true. So now this block is going to get executed. Okay. So f is equal to 0 and r equal to 0. So what is the meaning of this statement? First, I must have to bring the two pointers inside my queue data structure and then only I should initiate inserting the elements. Isn't it, friends? So now bring the pointers 0. So f is equal to 0 and r equal to 0. So bring the pointer as here, f and r. Now I am going to insert the element. Since it is insertion, we are just mentioning the rear pointer. I can also use q of f equal to item. Both are right only, but since this is an insertion operation, we are giving focus on the rear pointer, isn't it? So front pointer will be placed in the same position. Okay. So now q of rear is equal to item. So what is q of r? That is q of 0. So q of 0 is item. For example, let the item element be 55. Now item 55 is being inserted into this data structure. Okay friends, now the loop is being completed. So now we are going to start the operation from the beginning. So now if you see I value is 1 now, isn't it? So once again you start to check all the if conditions and which is appropriate, so that statement will be executed. Okay, so now if you see, let me erase this, if equal to so first if condition is r is equal to n minus 1. So now if you tell me what is the r value, so r value is 0 now currently, so this is 4. Is this condition true? So this condition is false. So now it is going for the next else part. Else if f is equal to minus 1 and r is equal to minus 1. Is this condition true? No, because f value is being 0 and r value is 0. So this is also false. Now which block is going to get executed? So this block will be executed. Okay, so now what I am going to do? We are going to insert the remaining elements of the queue data structure, because already an element is present. We are going to fill the remaining positions. So increment the rear pointer. So now r value will become 0 plus 1, 1. So now the rear pointer is going to point out here, r, right? So r is equal to 1. Q of 1 is equal to item. So insert, let the element be 61. I have inserted an element. So now this block is being completely executed. So once again it is going to start from the start. So now I value will be 2. I value is 2 now. So once again you do the same conditional checking. So once again you see, now what is r value? So r value is 1. So once again this condition is false, it will not execute. So again you check, so this condition is also false, this will not execute. So directly it will go for this else part. So now r value will be 2, because r is 1, isn't it? So 1 plus 1 is equal to 2. So now where this r pointer is going to point out? Here, to my second position. So now let me insert this element. So q of 2 is equal to another item. So let it be 34. Okay friends, are you all clear now how these conditions are being checked and how the loop is being operated? Okay, so now next I'm going to increment the I value. So let it be 3. So now once again you check. So now rear value is 2. So once again this condition is false. So this condition will also be false. Again you execute this statement. So now what is r value? R plus 1. So r is going to be 3. So q of 3 is equal to any item which I am going to insert. So increment the rear pointer, third position, isn't it? So 3, insert any value, that is 10. I have inserted a value 10. So now once again we are going to execute the loop. So now what will be the I value? So I value will be 4. So you simultaneously check this condition also. So 4 is less than 5. So this condition is true. So this loop is coming under. So again you see 3 is not equal to 4. So this is not executed. So this also will not be executed. So now you come here. So now r value is 4, isn't it? So 3 plus 1 is 4. So q of 4 is equal to item. So increment, according to this statement, you increment r value. So insert the element as 71. Any value, okay. Randomly I am just inserting. So now if you see, that is if you view this data structure, all the elements are inserted. That is, according to it, the queue is full. If any elements is coming in the future, we cannot able to insert, isn't it? Now shall we see how it is being operated? So now what is r value? So r value is equal to 4. Now these two conditions are true, isn't it? So it will print as q overflows because r is pointing to this location. Okay, so r is pointing to this location. So it will print as q is overflow and it will come out of the statement. So break is for that purpose only. So break is used for exiting from the entire loop operation. Okay friends, I think so now you will be clear with this queue insertion operation. Okay, so suppose if you have any doubt in this area, please mention it to me in the comment section. I am there for clearing your doubts. So in the next class, we will see how to delete an element from the queue data structure. That is how the deletion operation is being performed. Okay friends, bye and thank you for watching.